Okay, so the question is, if I get in an accident, would I rather be in a 1959 Bel Air
A 59
or
Bel Air.
a 2009 Malibu, basically?
59
So would
Bel
I
Air.
rather be in an old car, big heavy car, or a new little car?
I'd be
I
in
like the new
Bel Air.
one.
Depends what kind of accident.
Look at your CBX Online course resources and how to use some of its helpful features.
Okay, hold on.
Launching a course from your account.
Someone
Bring you to the
has their
front page
mic
of the
on.
course. On the
Yes,
left-hand
what is
side of this
that?
page, you will find a
You
navigation
can't
door
hear me?
containing
Who
links
the
to the
hell?
popular areas of the course.
I got people that are playing their mic. Turn off your mics. Thank you.
Grade book or calendar.
What is that?
So you can't hear me, Mr.
is-
Brain, or what? No?
That is someone playing with the controls on getting into the class already, and be getting into the online stuff. They have their speaker on, and that's what's coming over. So let's see. There you go. All right, so I can see some different input here. Metal and chrome, 1959. Little car, better crumple zone. 2000 has airbag, safer. 09. So we got some good feedback here. And let's see.
The newer is safer, no?
Well, we'll find out here just a second.
It
The
depends
new
what
one.
kind of accident.
So let me share my screen with you. And let's take a look and find out.
Holy shit.
Oh,
That's the insurance.
Oh, you see? The
That's-
new one is better.
Told you.
2009 Chevrolet Malibu in 1959 Chevrolet Bel Air. In slow motion, you can see the differences in how the new and classic cars perform in this version of the traditional frontal offset test. The Institute conducted this test to commemorate its 50th anniversary. It dramatically shows how much improvement has been made in passenger protection since the nonprofit organization opened its doors. The two cars collide in an explosion of metal, glass, and plastics. Where the Malibu crumple zone absorbs much of the crash forces ahead of the windshield, the Bel Air structure allows the lighter car to compress the passenger compartment. The impact is made worse for the Bel Air driver by the lack of airbags, head restraint, and even a seatbelt.
Now, did you notice how that steering wheel came up right into the person?
Yep.
Damn.
Because prior to 1967, steering columns were a
Collapse.
solid piece of metal. They did not collapse. So that's kind of like a javelin going right into the driver. So 1967 saw a lot of safety updates, including seat belts, collapsible steering columns, dual reservoir master cylinders. So
Even
cars 67 and newer are much safer than cars older 67. They're still not as safe as today's
Wow.
cars, but that was a big safety thing for them. Someone else had a comment?
mm,
All right, let's take a look here.
The
so
headrest.
basically, this car didn't have anything.
No, it didn't have anything other than a lot of size, right?
So basically, that was an accident waiting to happen. That car was an accident waiting to happen.
Yeah, and I'm getting picked on here because I didn't ask if we wanted to survive, just what we wanted. All right, I didn't say get in an accident. Which would you rather be in? Apparently, being in an accident, and surviving, I wasn't clear enough. So take a look here. Also, take a look at the door. See the door here on the Malibu stayed in place.
The Bel Air receives a full rating across the board. On the other hand, the modern Malibu provides good protection, with the dummy movement being well controlled. Measures indicating low risk to most body regions, so a foot injury would be possible. Beyond the safety gear, advancements in vehicle engineering give the Malibu a clear advantage in this matchup. While classic cars are often considered to be rock solid, This 59
Watch the door on the
demonstrates how much better
Bel
today's
Air.
cars are. And the IHS has played a key role in driving these advancements.
Damn.
At the range.
The Institute has made a real impact. The roads today are safer. For complete safety information, subscribe.
I mean, even the tire, no?
Yeah, pretty amazing, isn't it? I mean, when you think about safety things, you don't think of door latches, you don't think of door handles, you don't think of how the door stays in place, you don't think of how the seat's bolted in, you know. I mean, we kind of think of just airbags, but it's really all part of a system, the crumple zones, everything. So when we do repairs on vehicles, we do things on vehicles, we want to keep that in mind to maintain that safety.
Even
Does that
the,
depend also how many miles per hour?
the
I do not remember how, it does say somewhere, I do not remember. It's in the documentation because this test is standardized. And so I do not remember how fast they're going, but it is a standardized speed. I just don't remember what it is.
Okay.
Pretty amazing though, isn't it?
That's crazy how the
Yes.
cylinder just got smashed up like that.
I've had a lot of classic cars, and let me tell you, I sure, you know, once I learn this, understand this, I'm a lot more nervous driving an old car than I used to be.
Mm-hmm.
it's normal. Even
But
the
shouldn't be-
headrests.
But there was, well, it shouldn't be a safety thing at least, you know. I mean,
The old car?
What do you
Yeah.
mean it shouldn't be a safety thing?
it should be a safety thing.
There is none
Oh,
because of an
absolutely.
old
It's a-
car.
Totally a safety thing. And, you know, we don't always think about that when we're in a car. And you can see, I'll play this again, you can see how much the airbag and everything else and the crumple zones really protect the driver in the Malibu.
Institute for Highway Safety's front crash of a 2009 Chevrolet Malibu and 1959 Chevrolet Bel Air. In slow motion, you can see the differences in how the new and classic cars perform in this version of the traditional frontal offset test. The Institute conducted this test to commemorate its 50th anniversary. It dramatically shows how much improvement has been made in passenger protection since the nonprofit organization opened its doors.
If that's for the highway safety, they gotta at least be going right or something like that.
Metal, glass, and plastic. Where the Malibu crumple zone absorbs much of the crash forces ahead of the windshield, the Bel Air structure allows the rubber part to compress the passenger compartment. The impact is made worse for the Bel Air driver by the lack of airbags, head restraint, and even a seatbelt. As a result, injuries to the neck, chest, and both legs would be likely. Consequently, the Bel Air receives a poor rating across the board. On the other hand, the modern Malibu provides good protection, with the dummy movement being well controlled. Measures indicate a low risk to most body regions, though a foot injury would be possible. Beyond the safety gear, advancements in vehicle engineering give the Malibu a clear advantage in this matchup. While classic cars are often considered to be rock solid, this 59 demonstrates how much better today's cars are. And the IHS has played a key role in driving these advancements. In the past 50 years, the Institute has made a real impact. The roads today are safer for it. For complete safety information, subscribe to consumerreports.org.
So pretty amazing, isn't it?
Yes.
Oh, yeah.
Yeah.
So it definitely has an effect on what we're seeing and what is visible to us, and it should kind of make us think a little bit about the cars we drive and how important those safety features are. A lot of times people buy older cars because of cost or because they like the lines of it, and you know, I drive some older cars, so I get it. That being said, I also am well aware of that, you know, sometimes things are not as safe as I'd like them to be in doing that. And I see a ha here and then XD. I'm assuming that Shirley has a little Scion XD by that post. Is that correct?
Scion XD.
Hey, don't laugh. Those good little cars. So it is a laughing face. Okay. It didn't come through as that. All right. Also, someone clocked in yesterday just with a phone number. And so since I don't know all your phone numbers by heart, someone spent a lot of time in the class yesterday and didn't get credit because I don't know your phone number. So if that's you, please send me a message today. So, because I put 5 points up for everyone who was in class yesterday. So if you didn't get your points, get a hold
I
of
didn't
me.
get my points.
Who's that?
Benjamin.
You didn't get points yesterday, Benjamin?
I'll double check.
Double check and send me a message if you didn't, okay?
Yes, sir.
All righty. Okay, so as we're talking about these systems, introduction of our safety systems include lane departure warning, night vision
Yes.
systems, and supplemental restraint. I did upload this to Canvas, by the way. I haven't modified it. This is straight from the book manufacturer, but I did get you guys a copy. Entertainment systems have become much more widespread and sophisticated over time. So, I mean, when I got my first car, it was a big deal to get a cassette player in it with 2 speakers. You know, now people have what? Cars where the stereo system's worth more than the car. You know, so we've come a long way in sound. And then on top of that, what have we added? We've added infotainment. We want to see movies, we want to see videos. We want big touch screens. You know, like a Tesla has like an 11-inch touch screen on it. I mean, the things are huge, or 14 inches even optional. So we really want that connectivity. Manufacturers have introduced a wide variety of anti-theft systems and features also to vehicles, making it much more difficult to steal. That's why alarms, where they were very popular in the 80s and 90s, alarm companies aren't as popular now. It used to be the first thing you did when alarms first came out is if you bought a car, you put an alarm in it. Now they come from the factory with anti-theft systems. Here's a couple examples of screenshots. Here we can see night vision. This is off a Cadillac. Helps drivers see hidden objects. So you can see the thermal imaging there, the contrast of the person in front of the vehicle. And that's pretty cool stuff. So you can imagine if I'm driving, like when I was driving to the airport in Virginia, from where my daughter lives down to the city with the airport in it, it was pitch black. No street lights on the road, no nothing. I mean, it was completely dark, no moon, no nothing. And it was raining. So it was really hard to see. I was going, you know, speed limit real cautiously, and you really couldn't even see where the road was going. They didn't have good reflectors in the road or anything. So you could see where that thermal imaging, that night vision could be really, really important for driver safety. Manufacturers are adding more and more entertainment options. You can see not just function here, but also what they integrate with your phone, whether it's an Apple or a Android. So the level of integration is getting much larger. So one of the things in here talks about diagnosing operation of comfort and convenience accessories related circuits, such as power locks, power seats, pedal height, yada, 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 yada. We spent some time doing that yesterday. So that's kind of why I tipped into it. So we played with what? The mirror circuit. Well, the mirror circuit and window circuit are going to work very similar because what am I doing? I'm reversing the DC motor. So is my seat circuit probably going to work pretty similarly? Yeah, because what am I doing? I'm reversing the DC motor, which means I need to switch my positive and negative poles on the motor back and forth to get the different directions. So once I kind of look at how one of those work, and I've opened this up so you guys can play with some of the different objects in it, but one of the advantages of getting the online component, and one of the things that we are concerned about missing, is you're going to get more of that hands-on type here, dealing with some of these different skill builders that we have. And here, I'm still going to supplement that with stuff in Canvas. I want to do some demo videos and where you guys can fill out sheets and some other stuff. But I think this is a big step forward for us. Describe purpose and function types of cruise control systems. The book does a good job of this. It talks about the different types of cruise control, how we control them, and really how it's changed. So cruise control was originally developed to help eliminate driver fatigue on long trips. For me, it tends to work the opposite. When I worked in San Diego till 10:30 at night and drive home, I couldn't use cruise control because I'd fall asleep. And I needed the input. I was afraid of falling asleep. On cruise control, fall asleep at 70, it's going to be bad. At least now when I'm getting tired, I'm down to doing 50 and people are going by me and I realize I'm going slow. But the original goal of cruise control was to allow you to set a speed and then keep that speed. And it did two things. One, it increased fuel efficiency because you're not accelerating and decelerating, so you're more constant. And the other is it allowed traffic to flow more evenly, because if everyone's going this a constant speed, not doing that, stop, slowing down and speeding up, like we see a lot of times in the freeways, then traffic's going to flow smoother, less chance of accidents. So that was the original concept of cruise control. From there, now we've increased what it can do. So it no longer just controls the speed of the vehicle. I'll use cruise control on my car if I'm like coming into where it's a speed trap, but I know the radar guys on the motorcycle sit there and it's a 50 zone and I see people pulled over every day. I'll put my cruise control on 50 to go through that for those 5 miles or 3 miles. If I'm on a stretch of freeway where I know that they ticket a lot, I'll do the same thing. I'll put it on cruise control. That way I know I'm not going to speed and I don't have to worry about it. I did that when I was in Virginia. In Virginia, if the state police pull you over and it's a misdemeanor, it's a minimum $200 fine. If it's a vehicle infraction, like speeding, it's a minimum $500 fine. So needless to say, in Virginia, I didn't want to own $500 before I left the state. So I was using cruise control. So cruise control allows the driver to set the vehicle speed and the system maintains that speed. One of the issues we had with cruise control is what? If I have the cruise control set at 70 and I'm coming up on someone in front of me that's going slower, I would need to turn off cruise control or hit the brakes to deactivate cruise control. Otherwise, I'd run right into the back of that vehicle.
Like in LA, no?
Yeah. Or even here in San Diego County.
So this, the cruise control maintains the speed, like it doesn't, if you want to go faster, you need to take that off or something like that?
Yeah, you need to take it off.
A couple different ways we could do. Okay. So if I want to go faster, say I want to pass somebody and then come right back to the same speed, I can just put my foot on the accelerator pedal, drive faster. When I let off the gas, it'll slow down until I get to that speed that the cruise control set at. The other way I can do it is I have two buttons on cruise. One is called Set Excel. And so if I push the Set Excel button and hold it, that'll cause the vehicle to accelerate. The problem is when I let off, it'll go back to, it'll hold this whatever new speed I've just accelerated to. I mentioned hitting the brakes. If I hit the brakes, that turns off cruise control. So the brake input from the brake switch is really important. So say I hit the brakes, now I change lanes and I can go. If I want to turn cruise control back on, I can just push the resume button and that takes me back to the speed I'd already set in cruise control and I resume how cruise control was set. So those are the two main functions. And I see someone's cruise control doesn't work. The good news is I think the door opens now though. So one thing at a time. But the cruise control not working can be a couple different things and it's going to vary as we see based on the generation of the vehicle. So older vehicles had a separate little motor, vacuum motor many times, to open the throttle to make the cruise control work. Later vehicles might use the idle air control motor for that. Newer vehicles, we actually use the drive-by-wire and the throttle for that. And even though we're talking a little bit about drive-by-wire here, I'm saving my drive-by-wire article for when we get into induction systems and performance. So that, but if my cruise control doesn't work, just like any system, Well, if the brakes are on all the time, it won't work. So that's one thing. If it doesn't have power and ground, that'll cause it not to work. So I need to make sure I have power going to it. And then we're looking at, do the switches work? The switches that turn it on, and the switch that says set, and the set, and do those switches work? So I would test those inputs going to the little cruise control box. And I do see a note about mic. There's supposed to be something in here where I can turn off everyone's mic and you guys can turn them back on manually, and I'm just not seeing the control. So you guys need to be responsible for your own. So the driver controls built in the steering wheel or column turn the system on and off, allow speed to be set, provide deceleration and acceleration controls. Mostly installed as original equipment accessory by the manufacturer. Matter of fact, they all are now. It used to be we would buy cruise control in a box for around $100, and we would actually install cruise control on a car that didn't have it. Manufacturer equipped systems enable better integration of the cruise control into several vehicle systems. One of the three basic types of main actuator controls: throttle plate, electric or vacuum or electric operated. The electric actuator is a reversible motor that uses a reduction gear. The vacuum operator, which is all the old systems were, so if the cruise control didn't work on an old system, first thing we do is check see if the vacuum hose had fallen off. And about 80% of the time, that's why it didn't work. So they use vacuum, a little vacuum operated servo, and then electronic style, a DC stepper motor is used. So many of the ones in the 90s went away from vacuum. They used a separate electric motor built into a box that would have a separate cable going to the engine. So you'd have the accelerator cable, then you'd have a second cable coming from a little box about this big, and that would be the cruise control box, and it had electric motor in it, and that's how it controlled that. So the first trick in figuring out why my cruise doesn't work is figuring out which system I have. And I can do some of that by opening the hood and looking. I can do some of that by looking at manufacturer service information. So here's a couple types. Here I have an electric actuator. Has a little motor in there. And that little motor is just pulling on a cable. And that cable is going to pull open the throttle just like your foot would. And it holds it there. And it looks at the vehicle speed. And if the vehicle speed starts going too fast, like going down a hill, it's going to what? Let a little cable out. If you're going up a hill, it's going to pull a little cable in to maintain that speed. Just use your foot would on that cable if you were doing the driving. Here we're using a vacuum. Before we had computers and all that stuff, the early systems just used vacuum. So we used intake manifold vacuum coming to the throttle. And we use that along with a control in order to set it and hold it. And we just hold that diaphragm. And the early systems didn't work as good as the later systems, but they still worked amazingly well. But even by the 80s, we started seeing us go to that electric motor. And here is our electronic throttle. So the same throttle we use on a modern vehicle to accelerate with, because remember, I have no cable touching my pedal to the throttle anymore. It's all electronic. So what's the difference if the computer tells the throttle to open and go 70, or if my foot tells the throttle to open to go 70? No difference. So newer cars, that's why one reason why cruise control is so standard now. It takes almost nothing to put it there. The controls are already there. Only thing you're doing is putting a couple buttons on the steering wheel. Everything else is already in place. It's in place on every car. We already have the computer. We already have the throttle. So the question is, do you want to let the customer have a cruise control? Well, it's so cheap to add. Customers see that as a luxury feature. It helps manufacturers sell cars. So the principles of operation: cruise control system works by comparing the actual vehicle speed to a preset target. So in order to do that, I need to have what? A vehicle speed sensor. So on old cars, that would be up inside my instrument cluster and my speedometer, and I would have an output that came out of my speedometer. Newer cars, we use the ABS system. We use vehicle speed sensors. I might use a sensor in the transmission because there's some cars in the middle that just use a transmission speed sensor. in the days when we had to put these systems on cars that didn't have anything, we actually took a magnet, we used a zip tie and put it on a drive shaft, and it had a pickup right here. So every time the magnet would go around, it would generate electrical signal on a speed sensor. And we actually had to install that right on, and we actually would zip tie it right to the drive shaft. And that was the install. So one of the complaints used to be a cruise control didn't work. It was aftermarket. We'd look underneath to see if the zip tie was still holding the magnet on the drive shaft to make the thing work.
Zip ties.
What's that?
Using zip ties?
Yep. High-tech zip ties.
Jesus.
Hey, you know, for a $120 kit, what do you want?
Pretty Mexican.
Hey, you know, it worked. So cruise control maintains the speed of the vehicle until the driver turns the system off. Driver steps on the brake or pushes in the clutch pedal, or the system detects a loss of traction. Loss of traction is only going to be on newer vehicles where we have traction control. Cruise control components can be split into driver controls and system components. So here we kind of see where we have a cruise control ECU. A lot of cars, the cruise control ECU is actually part of the powertrain control module. We see we have power going to it. And I have an on-off switch. Do I want the cruise control to be on or off? I have the coast resume switch that we talked about. I have the set, which allows me to slow the vehicle down. My set increase allows me to accelerate the vehicle. And some of them also have another decrease button. But normally they only have the two, the coast resume, the set increase, and then you have an on or off. And then here we have a brake switch and a clutch switch if it's equipped. It'll deactivate the system. So those are simple on-off switches. They send a ground signal to the computer. If the computer sees a ground signal, whoa, we don't want to do that. Turn it off. And then we have a throttle motor, which is the only output from the computer, and the vehicle speeds and input. So it's basically looking how fast am I going? I want to stay in this narrow range. So I'm going to add and decrease throttle to stay between, you know, 50.1 miles an hour and 50.3 miles an hour. And I'm just going to do that. The older systems might have a 5 mile an hour range, the old vacuum systems. So the driver controls the on-off switch. So if my system didn't work, I'd want to test that switch. They go bad. I'd want to test fuses and powers going to the module, especially if it's a standalone module. If this is a newer vehicle, I probably have data on my scan tool where I can put my scan tool in, go to this system, hit the buttons, and look at my scan tool, and it'll say on, off, or yes, no. It'll tell me if the buttons are working, which is much quicker than taking everything apart and putting a meter on it. So we need to keep in mind when we diagnose this, what generation car am I working on? What am I actually working on? That's should get me a mental list of tools I might be able to use. Is it in every scan tool? No. How do you know it's there? Plug it in, go look, see if you can find it. If you can't, hey, it's worth wasting the 3 to 5 minutes to do that. If you can't find it, then start taking the car apart. If it's an old car, it's not going to be in the scan tool. And I got to be careful with old car. Old car being, sure, it really depends. GM had these in 2000. GM had this stuff in their scan tool. Toyota and Honda did not. So it really is going to vary by car manufacturer. System components include the electronic control module, which, as I said, is normally the powertrain control module, clutch switch, transmission gear. Cruise control system is activated by turning on the switch. Newer systems use an electronic throttle control, also called drive-by-wire.
No more.
And like I said, I'm going to get into this more and the reasons why we do it when we talk about air induction and performance, because there's some real performance reasons why we do this. But from a cruise control standpoint, basically it's an electric motor that opens the throttle, and that electric motor can either respond to my pedal that I push down or to the computer itself, because it's using the same computer. Like in this case, normally the PCM is what opens and closes the throttle. So why would I have a separate computer for cruise control? I wouldn't. I've already got all the functions going into my PCM. Just add a little bit more code in my PCM and we have cruise control. So cruise control is integrated in the engine control system. It does not require additional throttle actuator. There is no physical connection between the accelerator pedal and the throttle. Well, if there's no connection, I probably want this thing to default to be mostly closed, don't I? So if I unplug the electrical connector on this, I don't want it wide open because my car would take off and never stop. So these are actually spring loaded down to about a 16% throttle opening, which gives us an RPM of about 12 to 1500 RPM. That's it. So when this came out, you heard a lot of people about, you know, the car's running away. It has a mind of itself. It's taking off. It's impossible for this system to hold itself at wide open throttle. The only way it can go wide open is if there's an input telling it to go wide open, such as, oh no, a match is stuck on the accelerator pedal holding it to the floor. Someone's pushing the gas pedal to the floor instead of the brake pedal to the floor. When Toyota did research on this, on vehicle runaways, they found that the runaway condition where they got complaints happened to people over 65 much more frequently than people under 65 by a ratio of 4 to 1. So if you were over 65, your likelihood of having a runaway car was 4 times higher than if you're under 65. So either people over 65 bought bad cars, or there might have been something involved with some confusion or driver operation. Keep in mind, they're lumping people over 65, which includes people in their 80s and 90s. When I had my shop, there was a donut shop across the street. In the 5 years I owned the shop, we had senior citizens drive through the front of the donut shop twice because they hit the wrong pedal. So I'm not picking on older people. What I'm doing is I'm saying things happen. I've hit the wrong pedal before. I've hit the wrong pedal on my tractor. I've hit the wrong pedal off-roading. I've hit the wrong pedal where I've hit the gas instead of the brake, where I'm doing maneuvering, I'm doing stuff. I've hit the forward instead of the backwards, or the backwards instead of the forward on the tractor when I'm trying to maneuver something. You get distracted, or you're not paying attention or whatever. It's real easy to do. As we get older, we get distracted easier. I think it's because there's more stuff going on up here and we have so much more in here. It's harder to pay attention to what we're doing right now because we're so much smarter as we get older. That's what I'm going with. But you like that, huh, Mario? So
I'm on the pathway to the old. It's like
so it's not that we don't know how to drive. It's just we're so distracted with all the other things we know, we just get absentmindedly and hit the wrong pedal. So, but the electric sensor built into the accelerator pedal and monitored by the powertrain control module. There's also 2 sensors built into this that tells the computer the exact position of the throttle. So it's a true feedback system. How fast do I want to go? How much throttle angle do I give it? Oh, I'm slowing down, give it a little more throttle angle. Oh, I'm going too fast. I can close the throttle a little bit to maintain that speed. So very, very precise. So newer cars with drive-by-wire, which is going to be about everything from about 05 to 07 and newer. Very, very clean operation of the cruise control because of the drive-by-wire. The stepper motor is used to control the throttle, and the stepper motor is a DC motor. But what it does, instead of just spinning equally, it moves in steps. So instead of just spinning, it actually moves in steps, and that's why they call it a stepper motor. PCM adjusts the stepper motor to fine increments to control the throttle valve opening, so it gives it very, very smooth, very, very precise. And the advantage of a stepper motor is the PCM knows how many steps it's moved. So it knows, probably in its program, that on level ground, if you want to do 70, maybe I need 65 steps. So it knows that that should be that. And then from there, it can do the fine adjustment back and forth to actually match what you're doing. Or I can look at how much throttle you're giving it in steps, because that's a commanded decision. and look at the speed. So it's taking you with your foot on the throttle 80 steps to go 50 miles an hour. So let me move out to 80 steps. I'm going to hold it 80 steps. I've got 50. Now from here, I'm just doing fine adjustments to maintain that speed. So one of the big game changers we have, and part of ADAS, Advanced Driver Assist Systems, and I apologize, I had a video I wanted to play, and the link I got sent to my phone, and I couldn't get it to my computer, so I'm having Jessica resend it to me, so I'll play it tomorrow. But it's adaptive cruise control. And this adapts to the driving environment, also incorporates driver warnings for potential collision, requirements for driver intervention. Driver does not constantly have to adjust the cruise control in heavier traffic, requires additional sensors such as radar.
Right.
So these systems many of these systems either use a camera, radar, or both, depending on the manufacturer. And what I can do is I can set the distance, 1 car length, 2 car length, 3 car length, right, in front of me. So do I want to be really close where people aren't getting in, or do I want a long, nice, safe distance where people will probably pull in front? So now I can set my speed at 70 miles an hour. I can tell it what following distance I want. So I'm going down the road and I get into traffic. This system will come up to the distance, and then it'll match the speed of the vehicle in front of me. So if that vehicle slows down to 50, I'm now doing 50. I'm keeping that same distance. And that distance changes with speed because it's based on braking distance. Now, when we get out of traffic, that car speeds back up to 70. My car is going to speed back up to whatever I set the cruise control to. And this is really slick because some manufacturers like Cadillac and other ones, I can use this in stop and go traffic. So it'll take me, I can set it at 70 miles an hour. I'm coming into stop and go traffic. And we come to a complete stop. As soon as the car in front of me starts moving, my car is going to start moving. It'll go as fast as the car in front of me does up to whatever the maximum speed I programmed it to while maintaining a safe distance. Now, would that take a lot of stress off of stop and go driving?
Yes. The thing I read an article about that is like this system don't have a warning light. That's really dangerous. Even a millimeter, it's like change all the.
What do you mean not a warning light? This thing.
If is out of a calibration,
right?
You don't know, like as a customer.
Right. No, absolutely. You don't. And that's why it's so important repairs are done properly. Now, I'm adapting the adaptive cruise that would give me just the warning light I'm getting too close with my automatic braking system. So it takes 2 things. I'd have to have a level 2 autonomous vehicle in order to put those 2 pieces together. My automatic braking, you guys should have talked about in the 507 class for those of you that took Mr. Jackson's class.
I have a question. So, do all cars have the adaptive cruise control?
No, it is still optional even in 2020.
Really?
Yep.
Why? No,
Well,
seriously. What?
because it's newer technology and people are still willing to pay extra for it. So like a full ADAS package on a lot of vehicles is a $4,000 to $5,000 option to get the adaptive cruise, the lane keep assist, the backup collision avoidance, automatic braking, and they put it all in a package. So like when I looked at Toyotas recently, it was still a $5,000 option. My goal, especially since I'm not putting any miles on my car right now, because my goal is to make my car last for another 5 years. By then, I'm hoping that technology will be standard and I don't have to pay extra for it. They are talking about it being required in 2022.
Honestly, it does feel if this prevent any type of accidents would be good to have it, right?
Oh, absolutely. And the cool thing about this technology is not everyone has to have it in order to make roads safer. So when they did a study, and what they did is they had 10 cars in a circle going around, and they had someone come to a complete stop, lock them up. Well, once that happened, the circle never really got going again on its own. And then they took 2 of those cars out and put in 2 vehicles with this technology. And what happened is the circle never stopped going around, even though someone locked up their brakes. So it allowed, because of that technology. So they're actually seeing this as a green technology, because if they eliminate traffic jams, they can put more cars on the same road. People are going to get there quicker, fewer accidents, and roads are going to flow better. And the neat thing is not all the cars have to have this technology. The fact that some of the cars have this technology affects the whole group. Just like when we're on the road and you got one idiot who's braking for no reason, it causes all 4 lanes of the freeway to slow down. So just by integrating this technology is making everyone's road safer. But they are talking about in San Diego, the carpool, the express lane from Miramar up to Escondido. That they have there. And right now they have the white stickers that they're getting for the all electric vehicles to get on there without having to be in a carpool. The next one they're looking at is fully autonomous vehicles. And I don't know if we have it in this PowerPoint. And I see Edith says her Subaru Outback came with a warning if I'm approaching too closely. Yeah, the Outback, depending on which options you have, if you got that fully loaded with the eyesight and everything else, that car will actually drive itself down the road, stay in a lane, and stop automatically when a car in front of it stops. Subaru has some really nice ADAS technology. When I was up visiting my mom, she has a 2019, and she picked me up at the airport, and I had the car drive itself back most of the way to her house, which is about 45 minutes. Scared the heck out of her, but I sure enjoyed playing with the technology. She got real nervous with no hands on the wheel and no feet on the pedals and the car doing its thing. And keep in mind, it's a driver assist system, so I'd occasionally touch the wheel to kind of correct it. I mean, I was definitely ready to apply the brakes, but I wanted to kind of see how good the system was. And it got a little, kind of moved back and forth a little bit too much sometimes with trucks next to it or things. So there were some times I grabbed it to be safe, but it was fun to play with. It's amazing how good that stuff's getting. And I look forward to playing the video for you guys tomorrow on some cars I was in and talking about some of that technology, including some of the automatic stopping technology. Now, did you guys cover automatic braking in the 507 class with Mr. Jackson?
Yes, we saw some video also with automatic, something like that.
We talked about it a little bit.
Okay, so you saw some videos and talked about it a little bit. Okay.
We watched a video of a self-driving car
Right.
that drove, I don't know, what was it, 60 miles or something like that.
Right. And whose car was that?
Honda, I
I
think.
think it was Hyundai or something,
Honda.
actually.
Okay.
Yeah.
Oh,
So yeah, and you got to be careful. There's nothing on the road today that's self-driving. There is stuff that is driver assist, but we don't have anything that's self-driving. And because I don't think they put this in this PowerPoint. I don't remember seeing it. Let me pull up something. I'm going to share a screen with you here in a sec. Move this over. And there we go. Okay, so this is autonomous vehicles. This is what's called the 6 levels of vehicle autonomy. And so what we have here is, anyone can see that? Or not yet?
No, I don't see anything.
No,
How
nothing.
about now?
Yeah.
Yeah.
Okay. So what we have here is the 6 level vehicle autonomy. So we have, level 0. The car controls everything. However, it may have warning lights. It may have blind side warning. Okay, that's still a 0 autonomy vehicle. if something's just warning the driver still needs to do the action. So in order to get level 1 autonomy, I need something that the vehicle is able to do on its own without my input. So most functions are still controlled by the driver, but some like braking can be done automatically by the car. So this is my automatic braking system, or if I just have lane keep assist, or I have any one single function, or I may have multiple different functions, but they can't work together. By the time I get to level 2, I have at least 2 functions are automated, like cruise control and lane centering, and they work together. So now I can use cruise control, and my car is going to stay in the lane. I can even put a third thing where it's going to stop if a car in front of it stops. So I can combine 3 things. So that's going to be my level 2 autonomy, but I need to have at least 2 functions that work without driver input. And they need to work together. So I need to have at least 2 functions working together. So then we get to level 3, partial autonomy. Drivers are still necessary, but are not required to monitor the situation as with the previous level, at the previous level. So the driver still has to be there, still has to be ready to take over, but doesn't have to, but it's more than just keeping me in a lane, or it's more than doing the cruise. It's able to actually kind of navigate a little bit or do a little bit more. So partial autonomy. Level 4 is full autonomy plus human. So vehicles perform all safety critical driving functions and monitor roadway conditions for the entire trip. Keyword there is entire trip, with option of human driving. So you still have a steering wheel, still have brake pedals, but my car could take me there if I wanted to, or I can drive here. Then once I get on the freeway, I don't want to drive the next 5 hours going up north on the 5. I'm going to let the autonomous part do it, and then I'll drive by hand on the last part to wake myself back up. I have those options at level 4. At level 5, there's no option for human driving. There's no steering wheel or controls. You get in, there might be a tablet or a screen in front of it. You tell it where you want to go, and it takes you there. So any guess where we're at right now?
Probably most cars are about 1 and 2.
Yeah.
Most cars are
And
1 and
that-
2.
I think that video we seen was a 4. So like you were saying, there's no 5s.
Right. Well, there's some 5s in prototype.
Yeah,
They ran one around the Consumer Electronics Show at Vegas last year. They do have some 4s, a lot of 4s at prototype that they're playing with. Tesla is playing with some. You guys said you saw Hyundai. Those are still prototype vehicles. Currently, as far as something you can buy, the best we have right now is a low level 3. And the 2 that are low level 3 is Tesla and Cadillac. Those are the only 2 as of last summer that had gotten to that low level 3. Now, obviously, we've had a year of development. There's probably some other cars that are moving into that. But, you know, Tesla has its, you know, autopilot function. And then Cadillac has it's also its own function that works off mapped roads. The issue we have going from 2 to 3 is cost and technology. But the big issue we have is getting it to recognize things like street signs, getting it to understand what's that person going to do who's on the sidewalk, identifying that as a person who's on the sidewalk. They're pretty good at identifying people when they're moving. They do really lousy at identifying people when they're not moving. So when I look at semi-trucks, their pedestrian avoidance systems are all moving pedestrian avoidance systems. If you're not moving, it'll run you over. If you're moving, it'll stop the semi. So, and that comes down to the recognition software in the level of where we're at. The other issue is being able to recognize stop signs or stop lights. So currently both Cadillac and Tesla, which are low level 3 cars, if I'm coming off the freeway on autopilot, in the case of Tesla, if there's a car in front of me at the end of the off-ramp, I'm going to stop. If there's no car there, regardless of whether there's a stop sign or a red light, we're blowing straight through. We are not stopping because it can't recognize. Tesla last year was doing a bunch of stuff with software and some controlled environments, trying to get it to recognize and trying to get their artificial intelligence to learn the street signs and learn that stuff. But you think about it, freeways are pretty easy. We've been running semi-trucks in Europe for years, autonomously. And they run them in either caravans of 3 or 5 trucks. And they actually, if there's an on-ramp, they spread out, let cars go through them to the fast lane. And then between on-ramps, they get very close together and draft, just like NASCAR will draft to cut down on wind drag. And everything's controlled by the front truck. So if there's an obstacle, the front truck sees it, it sends out electronically that, hey, everybody needs to brake. So you don't need to worry about them running into each other. So freeways are pretty easy. We don't have pedestrians. We don't have people running across the road. We don't have cars coming in from side streets. Cities are hard. And that's where the big hang up right now. And that's why we're at that low level 3, even though we've built prototypes at 4 and 5, implementing them to the general public, we're not there yet. And it is interesting when this stuff doesn't quite work right, especially if you're in the car.
They look for the 5G, no? Like as a help for this technology.
That is one of the ways they're looking at doing it. So we're looking at a couple of different kinds of interface. I'm glad you brought that up, Mario. So at level 3 vehicles, or especially low level 3, vehicles for the most part aren't talking to anybody. They're looking at their surroundings. Hey, that's close. Avoid that. See that. In order to get high level 3, I need a couple interfaces. I need a vehicle to infrastructure interface. That's the 5G you're talking about. I also need a vehicle to vehicle interface. That way, when I come to a 4-way stop, the vehicles can talk to each other and recognize who's going to go first. Because what do we do here? Right? You know, right-hand rule, right? Whoever on the right is supposed to have the right of way. Does it always work like that when you get to a 4-way stop? Not even close, right? So what do? We look at driver's intent. We look at their eyes. We look at, are they nodding us to go, or are they actually going to go even though it's not their turn? Are they just going to roll through it even though the last car just went? They're going to skip and take an extra turn. What are they going to do? So one of the things they're working on is vehicle-to-vehicle interaction. So that way, when 2 autonomous vehicles come up to that, they're able to communicate and actually make that intersection much more efficient. So we do have that vehicle-to-infrastructure component. 5G is a big part of that, of what they're trying to do. And then the vehicle-to-vehicle component. And 5G may be a part of that also. And that's certainly what they're looking at. So we're in an exciting time. I like this stuff because this is the future. Does anyone doubt that we're going to have level 4 and level 5 vehicles in maybe 10 years? I don't. I'm looking forward to it because that means my kids won't be able to take my keys away and force me to move out because I can just get an autonomous car. It's going to take me to the store and the doctor. Right? You know, the whole discussion about taking away dad's keys, you know what? That's going to end when I get an autonomous car.
I'd still feel sketched out though.
What, with the autonomous car?
Yeah.
Yeah, but think about how many things we do now that someone 20 years ago would have been sketched out by.
That's true.
I mean,
Cars driving themselves.
Exactly. I mean, you look at Ring. I mean, we have Ring doorbells. So we have a camera on our front door. We have cameras in our kids' room for nanny cams, or we have cameras for security in our house. I mean, there's people 20 years ago that would have freaked out at the thought of having a camera onto the internet in their house.
Right. The life improve exponential.
Yeah, technology.
Yeah, technology. So, you know, and what we found over time, and I've been around long enough to see this now, is what one person says, man, there's no way they can do this, and there's no way I'll stand for it. The next generation tends to be very willing to accept it. I mean, when I started driving, almost everything had a manual transmission. How many manual transmission cars do you think they sell now?
Not that much anymore.
Not that much anymore. How about when I grew up, all the cars had crank up windows and a radio was optional. And now what? Every car has a radio and not many crank up windows. So things kind of change, and part of that's because of what customers' expectations are. You know, there used to be laws against having radios in cars because they were considered too distracting.
What?
Go ahead, Carlos.
You said what? What did you say again?
I said there was a time that
The radio
there
was
was laws
distracting.
against having radios in cars because they are considered too distracting.
That is crazy.
It is now from where we're at. In the 1930s, it wasn't.
Sheesh.
And my mom to this day can't drive the car with the radio on. It's too distracting for her.
I mean, we have to lower down the volume to park or if we're lost, so.
Yeah. So I
Is
see
that
some of
why
you
a
can't
lot of
wait.
the radios on the steering wheel now?
Yeah. Yeah, exactly. So what? Our radio controls are on the steering wheel, which makes it safer. And I see Vanessa can't wait. She likes AI. I'm with Vanessa. And the price of the car is going up. It was more advanced. Well, that's true. But what they do, and that's from Shirley, what they do is, you're right. The new technology is on those real expensive cars. But if I look at an entry-level car, a Nissan Versa or a Honda Fit, that technology 20 years earlier would have
Was a
been
dream.
$100,000 car and only available there.
Was a dream. Was.
Right. Think about color TVs. When I was a kid, color
Right.
TVs were $1,000.
I mean,
Jesus.
A nice black and white 19-inch was over 300, and that was on sale. So, you know, are TVs better now than they were when I was a kid, when you had the two dials and some little buttons and these ears sticking out the back, right? I think
It's how
TVs
thin the
are a lot
TV is
better
now. Yeah.
but they're cheaper. So as technology becomes more adopted, we make more of it. The cost for each one gets cheaper, plus the technology we're using to make it gets cheaper. So you're right. The price of the cars goes up for these features when we first introduce them. But each car has a price point. For example, people that buy a Toyota Corolla are buying cars at that price point. I can't make that Corolla $10,000 more because I put stuff on it. So I can only add as much technology to keep it at that same price point where it competes against other cars. So we see it first show up as options, like right now on a Camry, that's a $5,000 option package. In a couple of years, that's going to be standard. When I bought my car in 2012, the backup camera was a $1,000 option along with a couple other things in that package. Backup cameras are now standard on every vehicle sold under 10,000 pounds, and that includes the cheapest car on the market. And that was required from 2015. So suddenly backup cameras got a whole lot cheaper. When I got navigation on my wife's car in 2005, that was a $2,000 option for the 6-disc changer and navigation. Well, guess
What car
what?
was that?
What's that?
What car was that?
That was her Dodge Magnum.
Okay.
So, I mean, by the time you loaded that car out with the extra airbags, because not all the only airbags were standard were the front two. If you wanted curtain airbags, that was more money. Well, now curtain airbags are standard, aren't they?
You have to.
Right, exactly. So as we have these technologies and as they evolve, they become less expensive and more people are able to gain access to them. And to me, that's exciting. It also means that, you know what, this technology, this chart, if you want to look at the skills to work on cars, they're going to be around 5 years from now, 10 years from now, 20 years from now. This chart tells you all you need to know. Because let me tell you, we're going there because there's a huge push for us to get there, and customers want to get there, and the government wants us to get there. So these type of technologies, the electronics, the electricity, all the things we've been talking about so far in this class is all about this. If you notice, it doesn't say on here somewhere, this is a gas engine, this is a hybrid, this is a plug-in electric. Does it say that anywhere on there?
Negative.
No. Because it's immaterial to the technology we're adapting. How the car is driven, even though there's technology, a lot of technology involved with that, as we'll see, but it's really secondary to the skills I need, because the same skills I need for this are the same skills I need to fix an electric vehicle or a hybrid vehicle or a conventional ICE engine where it's using a gas or diesel engine vehicle. I'm using the same skill set. It comes down to that electronics. So does this help you guys as far as autonomous vehicles and kind of seeing what we're doing?
Yeah.
So I'd put it in my PowerPoints for this, but I'd not, it's not in this one. So I wanted to share that with you. All right, let's go back to here. And that means I can close this and see that again.
If you guys want to get an autonomous vehicle, I would suggest you get a Mercedes, because Mercedes said they were asked because they asked them this question, that if the car has to decide if, between hitting someone and getting you in an accident, Mercedes said that it would do what's best for the driver because he's the customer. You know what I mean? No, and that's the true story.
No, I can see Mercedes saying that. And what's interesting, you know, we're talking about the adaptive cruise control. Mercedes first introduced this in Europe. And a lot of things get introduced in Europe because we don't sue people as much in Europe like we do here.
Yeah.
And the first versions of adaptive cruise control, and I'm going back 20 years, had two issues. It didn't see around corners. So if I'm coming around a big sweeping off ramp with the cruise control on, it wouldn't see the car in front of me and I'd hit it. The other issue is it didn't see motorcycles. So Keith would probably be pretty bummed about that if that car is coming up behind him, because it's just not going to see him. So that was the two issues we had with first generation adaptive cruise that Mercedes had. Now it's interesting you mentioned Mercedes. Mercedes technology has always been about, and actually this goes for all Europeans, but the engineering philosophy has always been about safety of their customer. And so that really is helpful if we have one of these cars that doesn't work, because then I can go in and look at and put my mind in, if I was the vehicle, how would I want to keep my person safe? And a lot of times that's what's wrong with the car, especially when you have no codes. So if I have a system, and this goes for your Audi, Mario, or anything else, but if I have a car, European car, and we're starting to see this kind of carry over some to Asian and domestic, but it's still heavily a European concept, that if I have something that doesn't work on a car and I have no codes and I can talk to the module on the network, meaning the module's not dead, odds are it's doing something to protect the driver. So what I need to do is I need to take a look and see in my mind, what could the car be doing that thinks it's doing such a great job? I'm protecting my driver. I am awesome. And that's why you have no codes, because it thinks it's doing a perfect job. And you're right, Iman, that is really Mercedes technology. What you'll see, hopefully I can get the video up tomorrow and play. I was really unimpressed with Mercedes drive system in their lane centering and their autonomous and their driver assist mode. I did not think it did. Matter of fact, I was car sick after riding in the Mercedes, and that was the only car I got car sick in. And I was right behind the driver in all of these filming the video. And some of that could have been the guy who was driving it, because he didn't like the Mercedes, and you'll see it kind of spills over. But compared to the Cadillac did a much better job. Even the Subaru did a better job than the Mercedes did, even though Mercedes started having vehicles that said they had full autonomous information in them, going back to the E-Class in 2013. And yeah, Keith, you got to turn your mic on. There you go.
How long ago was that? Did you ride in the Mercedes in that?
That was last summer. I was in an autonomous vehicle conference or training. I got to go back to Dayton, Ohio. I spent a whole week back there doing nothing but autonomous vehicle training. So that was, we got to operate some
on a
vehicles.
bunch of cars.
We got to look at a lot of technologies, and I got to be there with 39 instructors from all over the country. So it was a really neat opportunity, both in the classroom and during the class, but also networking afterwards and BS sessions. And we did find a local brewery, and I mean, so it was all good times.
Yeah, it sounds like it.
But that was a lot of fun. So that was last year. That's what I'm saying. That's why I kind of said as of last year when I really saw a lot of this. I keep an eye on what's going on, but certainly, you know, vehicle manufacturing is moving so fast.
Now, with all that going on with, you know, the automatic braking system, wouldn't it just be like another code to add this advanced cruise control? Or
Yeah,
adaptive
it really
cruise
is.
control?
If I have cruise control and I have automated braking, then it's just a couple lines of code. All my hardware is there.
Yeah, I mean, most of the time they'd be talking to each other anyways.
Right. We already got the network.
I mean, it is literally like you said, probably 10 lines of code and okay, we're done.
Right. And what Tesla's done, which is really interesting, is all their cars starting midway last year have everything to be level 4 autonomous in them from a hardware standpoint. So all their hardware is there, and you already touched on that, Keith. If I already got the braking, I already got adaptive cruise, I already got lane keep, I already have all these things. All I'm missing is the software. So they're building all their cars with all the hardware, and then you can buy the software packet at a later date once it's ready to be downloaded and once it's approved. So that's their whole thing that they're doing. So that's interesting because we're so used to manufacturers going back to cost of vehicle and we're used to think of it as hardware as the cost. And what we're seeing now is hardware is getting cheaper, which is why it's available on lower line vehicles. And the software is what they really want the money for because that's the R&D part. So pretty cool. But you're right. All that stuff's there, Keith, if the car's fully equipped.
If they're thinking about it that way, they're also thinking about people trying to keep their cars for the next 5-10 years, at least 5 or 10 years.
That's the
All you got to
business.
do is
Sounds
change the
like
software then.
Well,
right.
yeah, but actually Tesla is going a different way than that. What Tesla is doing is their model is you're only going to keep the car about 2 years. But what you're going to do to offset the cost of the car is you're going to buy the car and then you're going to let the car go drive Uber by itself. And then the car will be back when you need it. So if you drive the car to work, it's going to go run rideshare during the day. And then when you're ready to leave work, it's going to come back and it's your ride home. And the income from that ride sharing is going to offset your cost on the car.
Nope, not happening. Nope.
Yeah, I'm not okay with it either, but and that brings me back to the
Not gonna happen.
generational thing. I think that certain people by generation would be very okay with that. For me, I keep a bunch of stuff in my car. It's my car. And part of that's my cultural ownership to that car. I think, and I have a friend of mine whose daughter is, I think she's 21 or 22 now. She Ubers everywhere. She has no interest in owning anything. For her, it's about experience. She went to Dubai to go skiing with penguins. She's done all these things. For her, a car is just a tool to get her to her next experience or to get her to work so she can earn money for that experience. She's not vested in having a car. So I can see someone like that in her generation, and not just her generation, but certainly the millennials also, being willing to do that. Let's see, Bugs in Uber and Lyft card, yuck, and CV20, yep. There is that. I personally don't like sharing my stuff. I would not be okay with that. Yeah, it's fine for the car, maybe worker. So yeah, there you go. But what does that do for people that are driving Uber now? And yeah, she was wasting more money on an Uber. Yes and no. She worked downtown and had to pay for parking, so it was almost a push. But yeah, but again, that's the thing. I mean, it is interesting. One thing about life, it's always changing. So let's see, it's the same as riding in an Uber. Yeah. So yeah, I personally, if I had a car, I wouldn't do that. I like you, Keith, I tend to keep my stuff for a long time. I've had my wife's car. What do we had it now? 15 years. And When
The
we bought it,
Magnum?
we planned on keeping it for 20, and we'll probably keep it longer than that. Yeah, I bought my car. I anticipated keeping it for 12 years.
If I had a Tesla, I wouldn't let my kids use it.
Yeah. Why is that?
You know, because it's gonna be a nice car.
Right. But you can also limit certain features based on what key is being used. So you can turn a lot of that stuff off when you don't want your 16-year-old to be doing 100 in autopilot going down the
Oh,
road,
I'm sure
right?
he's gonna be. I'm sure he's gonna be a hacker, and he's gonna be able to do it.
I mean, that's when you teach them in the old car, and then you're like, okay, you know, after you learn, then you can use the new car.
Right. Yeah, I was just excited to have a car. I mean, my folks,
Yeah.
when I was young, my folks said, "Hey, we'll take you to get your license on your 16th birthday. As soon as you can afford a car and insurance, you can drive." So that was so I had a car 3 months before I had a license.
Oh, I started doing that at 15. They gave me my
too.
permit. And I was like, oh yeah, bye.
Yeah, exactly. It's amazing. You know, I got real good at marking exactly where my car had to be parked back and exactly how much gas was in things. I got real good at sneaking my car out. You know, all part of a misspent youth, right? And I do see the comment from Shirley, and that's a great comment. One of the things that we have connected vehicles, they know where they're at all the time. And they're already doing that with vehicles. I was talking to the mayor of Temecula about their traffic problem. And they said when Caltrans did the survey on the 15, they figured out that most of the people there were going north and not getting off in Temecula. And so they designed that, and they did that all off cell phone data. So they tracked the cell phones of people in the cars to figure out where the cars were going. So the Caltrans is already doing that now to figure out traffic patterns. So obviously if it's my car, then they're really going to know who it is. Now they just know it's a cell phone and yada, yada, yada. Do they know whose it is? Who knows? But it is, you're right. We are being tracked, and you hear them talking about the coronavirus and about actually, if you have the antibodies and you can go out, then you're going to be tracked and shown that you're okay to do that and actually have basically a code in your phone or papers or whatever saying you're allowed to be out because you've already got the antibodies and you can't catch it and you can't spread it. And I don't know if you've watched the news, but you've already heard people talking about that. I don't know about you guys. That scares the heck out of me.
That definitely scares the hell out of me too.
You know, I mean, I like privacy and I like civil liberties. I think we should all be able to be secure and private in what we do and where we go. And, you know, the thought that the government is talking about doing that under public safety is scary. You know, I mean, so, again, interesting times. So finish up on adaptive cruise here. So steering angle sensors are used to determine the vehicle. So one of the questions came up, what if it's out of calibration? Well, if someone did an alignment and didn't set the steering angle sensor properly, 1 degree after half a mile is a huge number of feet. You know, even at 100 yards, it's going to move you off. So you can see even at a couple hundred yards, 1 degree is enough to where it won't see the car in front of you. So it's pretty staggering. So all these adjustments, all these things really have to be done correctly. And it talks about the automatic braking. So testing the cruise control system, it talks about verifying the customer concern, research service information on how that system works. For vacuum operated system, perform a visual check of the vacuum hose. I mentioned that already, in addition to electric circuitry. For fully electronic throttle system, use a scan tool to access any DTCs, research and retrieve codes. Typically a digital multimeter or lab scope will be used to test the wiring and components of the system. A lot of these systems, we're using lab scopes now because we actually want to see what kind of signals are being sent out and brought back, and it allows us to compare. For example, since I might have 2 sensors in there, wouldn't it be helpful to compare the 2 sensors at the same time and see how they move? And it's real hard to do that just looking at numbers, but if I graph them, then I can really watch them move, or if they move opposite, I can watch one go low to high, one go high to low, and do that. I can look at the relationships and see that problem. I'm going to see it very quickly. So we've gone to using scopes for a lot of this stuff. Make sure you identify the root cause of the concern. Once the system is repaired, perform a test drive and operate the cruise control system to verify it's been resolved. Most cruise control systems won't work below 20 miles an hour. So if you go out at 10 miles an hour, they won't work. If you try to use them on the rack where only 2 wheels are turning, they won't work. They need to see all 4 wheels turning. One reason, and on older cars, you might be able to get away with it, but usually doesn't work well. But on newer cars with ABS, since we're using ABS for the speed sensor, it sees 2 wheels not turning. I get an ABS code. Cruise control is deactivated if I have ABS codes, because what? I'm using ABS for my speed sensor. So if ABS has a problem, how can I trust my speed sensor? I don't know what code set. All I know is I have a code. We're not going to work because I can't trust what he's telling me. So as we get in these network systems, like I talked about yesterday, a lot of it is, hey, if this doesn't work, and what happens sometimes, the customer says, I don't care about ABS light being on. I just want my cruise control to work. And we need to educate them that, hey, I really need to fix the ABS first, because I have no idea if cruise control is going to work before, but I need that input. And sometimes that's a bit of a hurdle to go over with the customer. So collision avoidance systems, I talked about that a little bit. And so things such as horn, airbag, seatbelt pretensioners, and so on, collision avoidance systems are designed to help avoid collisions or minimize the severity of the collision. So we're constantly integrating new parts into the system. Excuse me. My lozenges were out of reach. So we have now what are called active suspensions, where we can adjust the height of the vehicle based on the weight in it or based on cornering or what's going on. So we actually see where on some of these vehicles, if the radar detects that someone's coming in and going to hit the vehicle on its side, it'll actually drop the one side and raise the other to brace for that side impact. It'll also roll the windows up. So that way it keeps all your body parts inside.
Wow.
It also gives, so the car's doing this instantly off the side radar as the car's coming in. We're doing this. What do you do if someone's running into you? Don't you kind of brace and go down and get ready to kind of brace for them to hit you? I mean, anyone who played football or anything did like that, know that you kind of get
Flex
down
up or whatever.
We're doing that with cars. Or for me, it was soccer, which is a full contact sport.
Yeah, it is.
Absolutely. So as long as you're going for the ball, right?
Oh yeah.
So
especially if you're a keeper.
Yes, especially. But that was the fun thing about playing defense. So the cars are really, so when we think of this, we got more and more systems. And going back to what Keith brought up earlier, since these systems are on the car, now we're just talking the lines of code to integrate them, to get them to work together in new ways. So I think we're going to see the acceleration of these technologies over the next 10 years. Not just introducing new technologies, but finding new ways to use them together. So common collision avoidance features include adaptive cruise, pedestrian detection systems. I did mention they really only like to see moving pedestrians. Side collision avoidance, which goes in with my lane keep assist. Rear collision avoidance for when I'm backing out of a parking spot. Lane departure warning. No, warning is not avoidance. Warning just means a light or a beeper telling you to do something. Avoidance means the car is doing something. So I want to show the difference in those terms. Driver fatigue monitoring, the coffee cup on the dash. Night vision systems, we talked about. Active headlight systems, we talked about those. Pre-crash systems designed to give the driver a warning about a potential collision. So beeping, for example. So collision avoidance system, here we have an audible alert, obstruction to the left, steer right. It lets you know that, hey, you're changing lanes and there's a car there. Are you changing lanes because you're reaching for your cell phone over here? Or are you falling asleep? Or are you actually trying to change lanes and didn't see the car? The system doesn't know. Its job is just to warn you. And they do it in different ways. Some are just an audible alert. Some are a visual alert. Some are direct interaction. The steering command, if I'm moving over, the steering will actually move back to avoid the collision. Electric steering makes that possible. So cars, electric steering is an advanced driver assist function. I know you guys learned about electric steering in the 507 class. The electric steering not only gives you the electric assist, it gives the computer the capability of steering the car. So now we're down to code. Electric steering's been around for a number of years, and the steering angle sensor's been around for a number of years. But now what? I want to steer the car. Now we're down to code and a couple other things. So they're able to do these different functions actively. We can apply the brakes. We can steer the car. We may need to tighten up the seatbelts if we know a collision is inevitable. Precast system can sense where the driver's attention is focused, whether the driver is drowsy or take more aggressive action. So there's two different ways we can do this. Cadillac uses a camera that's actually facing at you the whole time. If you look away from the camera for more than 8 seconds, it starts letting you know there's a problem. The other systems use the input from the steering angle sensor. So they're looking for torque change as your hand's on the wheel. It changes torque on the steering angle sensor. So they have the angle sensor. They also have a torque sensor. And they're actually able to measure the torque on the steering column. And when your hands on the steering column are moving it, they're able to see that you're active. If your hand's not on it, it's only going to go a certain period of time, usually 20 to 30 seconds. And then it's going to say, hey, we want some attention here.
Probably in the future, they add learn your style of driving.
Yeah.
Adaptive, right?
Yep. Absolutely. I mean, they know the worst thing about a vehicle is the driver. Okay. In lane sensor, I'm not sure what lane sensor is.
My mother-in-law has actually her Toyota Camry, 2018. It has a kind of like lane sensor. So when you're swerving and you don't put your, you're gonna switch lanes, it starts beeping at you, kind of like going straight, not swerving back and forth.
Okay, so lane, L-A-N-E sensor. Okay, yeah, you're right. So that is our lane, either lane departure warning if it just warns her. It's lane keep if it can actually move the steering wheel and put her back in the lane. So she may have, if she either has one or both of those systems on her Camry.
Yeah, it like moves you back in your lane, kind of like telling you, hey, just go back in your lane.
Exactly. So she actually has lane keep assist, which is an autonomous function. So the warning, hey, you're moving out of your lane, that's just a warning. As soon as the car turns the wheel to make you come back into the lane, that's assist, that's autonomy. So most manufacturers move the steering wheel. Mercedes does something different. What Mercedes does is if my car is drifting to the left, it'll apply the brake on the right rear and cause the car to pitch back into the lane. And so they're using the brakes to steer it. And their philosophy is that if we move the steering wheel, it might make our customer uncomfortable or scare our customer. So we're going to use the brakes to pilot it, kind of like you would with the motors in a boat to steer, and move that over. And that way the driver doesn't, it doesn't affect the driver experience holding the steering wheel. So different manufacturers have different ways of accomplishing that, but it's really cool. And thanks for
So
sharing that,
delicate.
Shirley. What's that?
So delicate, them.
Yeah. So pre-tension seat belts, which we'll talk about, pre-positioned seats and seat backs. So we actually might move the position of the seat in the event of an accident to where the airbags will be most effective. Roll up windows, close the sunroof. We don't want you flying out the top. Apply the brakes to precaution them from panic braking. Apply brakes automatically if the driver cannot take effective action. Steer the vehicle away from an impact zone to a safer place. So the manufacturers and engineers are convinced the worst thing about a vehicle is the driver. And this comes from European philosophy. Mercedes, I have a video up here. I should probably try to put it on to DVD because it is actually Mercedes stability control going back to the 90s, and it shows like an early 90s, late 80s, early 90s car with stability control. And it even talks at that point about Mercedes. The reason why cars get in accidents is drivers. So the more things we can take away from the driver, the more we're going to protect the driver. And that's their philosophy. And it has been for 25 plus years, is that the more things that they can keep the driver from screwing up, the safer the driver is. So here's a collision avoidance system. We've seen this picture or something similar to it with a night vision camera already. So proximity sensors and backup displays. Proximity sensors can be mounted in the front or rear bumpers of the side of the vehicle and allow for safe parking or backing. Color matched piezoelectric sensors emit ultrasonic sound waves to transmit and receive coded sound waves. So we can actually test these with a scope. I have an adapter that goes on my lab scope, and I put it about this far away from the sensors, and I can measure and make sure the sensors are actually working. So that's one way I can diagnose those. The control module determines the distance between the sensor and the obstacle, measure the time taken for the sound wave to leave and return to the sensor. Proximity to obstacles can be indicated by separate audible and visual alarms integrated in the sound system. So a lot of displays, maybe I have 4 proximity sensors, it'll light up and show me which of the proximity sensors is seeing that. One of the things we got to play with on these is we actually started putting tape over these proximity sensors to see how much tape it took before we could cause it to get to not work and hit what we were backing into. And let me tell you, it took a lot of tape. But that was fun. So we spent time with these. We actually had a crash dummy car that we were crash into. And that was enjoyable. So I got that on the video. Hopefully I'll have that up tomorrow. But that was kind of interesting. And we played with different things on that. So this is a neat system, pretty low tech, been around a long time. That's that beeping that you hear when you're backing up and you get close up and you get beep, 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 beep. That means you're real close. Okay, time to go the other direction. Helps people parallel park by methods other than Braille. Old cars with the heavy bumpers, you just did it by Braille, right? You backed up till you hit one bumper, went forward to hit the next bumper, split the difference, you're parallel park. But now we got beepers for that. And it is funny messing with the cars. You know, I love messing with cars because that's how I learn. You know, hey, this is how it's supposed to work. Well, what would happen if we do this? What would happen if this becomes unplugged? What's it going to do if we do this? That's how we learn about things. I love that. So here's some pictures of some proximity sensors. On the right side is the backup camera display. And the backup camera display is not supposed to be part of the automatic braking. Only the proximity sensors are. And we did play with that some. We covered different things up again. Because what we find is there's what the manufacturer says how it works. And then, okay, let's see if it actually works how they say it does. And the only way you do that is by playing with it. I've gotten in a lot of trouble before going to classes.
Mr. Brian?
Yeah.
So in older cars, well, not older, I guess the same car, the older model cars with proximity sensors, on some of them that don't have the camera display, don't they have like a little like a mill on the dashboard that says stop?
Yeah, they have a light and they usually beep. So the proximity sensors and camera are 2 completely different things. 2 separate systems. So the proximity sensors, we had proximity sensors a long time before we started putting cameras on things. So 2 separate systems. They're both, the reason why they're here is because, and it says, that's why it says proximity sensors and backup display. I think the book manufacturer put them here because they both deal with backing up. Another interesting thing about backing up is these newer systems. The old systems, the sensors just would tell you you're going to hit something and you hit it. The new systems will actually apply the brakes. And what's interesting is several of the systems don't apply the normal brakes, they apply the parking brake. So they're actually activating just the parking brake in the rear calipers to stop the car when you're backing up.
When did that car cause the car to start spinning? If they had to do it too hard? Like
No,
start
because this
to kill or
system only
something?
works at low speed. So you're only working at low speed on this. They probably put a speed of 5 or 10 miles an hour or something like that where they're using that system. After that, they're going to use the service brakes and the normal collision avoidance with the radar.
Does it also apply the brake light when it does that? Because I know
To the outside, yes.
Because I know a lot of times if like you manually pull up your parking brake, the lights don't turn on.
Correct. They won't. They're not part of that circuit. But yes, because it's computer controlled, great question. Because the car is stopping, the computer turns on the outside brake lights. That's the advantage of a network system. Great question. So side sensors are used in collision avoidance systems. The side sensors for the collision avoidance tend to be radar sensors. Backup cameras and displays use a camera mounted on the rear of the vehicle. And the camera's image is displayed either on the rear view mirror or the entertainment system. And it says things what are larger than they appear, maybe closer than you think. Some cars have multiple cameras on them where you actually get a 360-degree view. I was playing with a 2020 Nissan Pathfinder, getting some lap scope patterns and taking bumpers off. We rented a car. So what do you do with a rental car? You take it apart and see how things work, right? So
Yeah, that's what I do usually.
yeah, absolutely. So, hey, I've always been able to get them back. It's amazing. I had one that I was a little concerned about. I had a Chevy Cruze years ago that I rented when I was up in Sacramento, and I had that thing really upset. It would not move. And I had to get that thing reset, and I finally got all the lights out so I could drive it and return it. I've never had one I couldn't get back, but I've had some that were not as good as they were when I picked them up.
Also, I think the F-150 has a 360 view, and
Yeah.
with the trailer thing, I think.
Yeah, and what they do is they're putting cameras on the mirrors.
Yeah.
So you got the 2 mirror cameras, front and back camera, and it gives you that virtual view from above. BMW is one of the first companies that did that. And it is cool. It really is neat technology. So let's look at our supplemental restraint system, SRS for short, which is our airbags. Purpose of function, operation, supplemental restraint systems, and components. So refer to the passenger safety device such as airbags, seatbelt pretensioners. Modern vehicles have more than 6 airbags along with side impact protection. One of the newest addition is the pedestrian airbag. What the pedestrian airbag is, the airbag that's actually in the cowl that pops up over the windshield and pops out. So if you hit a pedestrian, it actually is going to inflate and protect the pedestrian from hitting your car. And what they're trying to do is increase survivability for people that are hit by automobiles.
Wait, from the outside?
Yeah, it's on the outside. Is that pretty wild or what?
Wow. Do they have like also on the front bumper? So if you run someone over?
Yeah, they're a little limited. Some of them do differently on that. Let me see if I can pull up a picture of one to kind of show, because I don't think the book had it.
That'd be neat. We can drive like in GTA. And not
Yeah.
worry. I've seen it in an Arnold Schwarzenegger movie, a very old movie in the 80s, I think. And when he lost control of his car, the whole thing turned to foam.
Oh, wasn't that iRobot with Will Smith, where the whole inside of his Audi turned to foam and he had to kick his way out?
Yeah, maybe they did that too there. Yeah.
All right, so I'm gonna share this screen. This is Volvo's thing. I've not seen this, so hopefully it's okay.
The new Volvo V40 is equipped with a pedestrian airbag. It's designed to help protect pedestrians in case of an impact to the vehicle's front.
Oh.
In traffic, where people and cars share the same space, it operates in speeds between 20 and 50 kilometers an hour. People are soft and cars are hard. And in order to try to cushion the impact, the airbag has two purposes. One, to lift the bonnet to create additional space between the bonnet and the hard components in the engine bay, like the engine. And secondly, to cushion the area around the windshield wipers and the lower part of the A-pillars. To deploy the system, there are sensors along the bumper edge. These advanced sensors have been developed to recognize an impact with a human-like leg form. This is unique technology, tailor-made for the new Volvo V40. The system has gone through extensive testing and computer-aided engineering in order to verify its performance. Performance both in different impact situations, as well as in different road and weather conditions. Along with our pedestrian detection with full auto brake, the pedestrian airbag technology is a grand example of how we work holistically with safety here at Volvo.
So what do you guys think of that?
I have never seen that before.
So you learned something today.
Yep.
I
I'm
thought
so glad I
that
had to see that.
inflatable thing was kind of weird. What's the point of that?
People,
What's the point
for
of the
people that
inflatable
don't-
thing? To
for
keep
people that
the
don't know how to
person's
drive.
head from crashing into the windshield.
I thought they were going to put
I feel
it
like
in
at
the
that
front
speed-
bumper
Yeah.
and they'd take people's legs out and watch them hit the hood.
That's exactly what I was
That's
thinking.
exactly what I thought in my head. I'm like, these people are going to do
Torn
this.
up by the time their head hits the window.
You know what's fascinating is even though this is a Volvo ad, this technology where it's really taken off and really where we saw it develop is in Asia. So this
So
is
we don't
actually
have that
a-
here.
What's
In
that?
other words. So we don't have that here. In other
No,
words.
we do have it here on some cars now.
I think that's going to be a more common thing in the next 5 or 10 years.
Oh, absolutely. It's real common in Asia, has been for a number of years now. Asian, because of its density and size, has a lot more vehicle to pedestrian, vehicle to scooter accidents. So they're very concerned with the fatalities caused by that. So a lot of this was developed in the Asian market, and we're seeing it now in European and domestic markets here coming in.
In
Europe
also, maybe.
So you guys saw an airbag you didn't even know existed today.
Yeah.
Cool.
You know, Mr. Tom told us once that in China, it's not mandatory by the law to wear a seatbelt, and it's a form of crowd control.
Yeah. China tends to have more people than they know what to do with sometimes, I think.
Yeah. I think the same with India. It's not required by law to wear the seatbelt.
Yeah. Well, also, traditionally in both those countries, not many people had cars. So the people that did have cars were more of the elite. You know, India still has the caste system where you're born into a caste. You're born into a certain class and you cannot move out of that class. So India is still a very class-based society. That's one reason why it's very popular for people that are in a lower class in India to actually do well, get a degree where they can immigrate to this country or European countries, because there's the only way for them to escape that caste system. No matter what their education is, they're still in that lower caste. Where if they leave India with a good education, then they're able to, you know, change social status. It's not open to them in India. So it is interesting how different countries treat and see their people. So here's an example of some different airbags. We got a front airbag, a knee airbag, a side curtain. I know when my Corolla got totaled, all the airbags deployed, and I was the only person in the car. But I got rear-ended and then pushed into a truck in front of me, so it just collapsed it down.
At what speed?
The car, I was stopped. The car behind me was doing 55, and he was texting and never hit the brakes.
Do you think that's warranted to deploy all the airbags, or was it overkill?
I think it was warranted because I was rear-ended at such a high speed and then pushed into a truck in front of me. The car could easily spun, and really the philosophy at that point, I think, was to try to protect the driver above all else. And the car was definitely a total just on the sheet metal damage before you even got to adding up the airbags. And I think that, again, trying to control the driver, trying to control flying things, the force was enough that I had a Bluetooth in my headset just on my ear, a little clipped on my ear. It went flying across the car. I was talking to my wife at the time. She said I was out for a couple of minutes.
Wow.
That happened to me too.
Yeah. Because all she heard from me is he's not going to, because I could see he wasn't stopping. And that's as far as I got, and boom. So, yeah, again, the airbags are really there to protect people, and cars are disposable. And that's really the philosophy, certainly, that we have here in this country, and the vehicle manufacturers selling products here have. A lot of cars are totaled just based on the airbags, even though it's a minor collision, because when the airbags are deployed, we can see here the side airbag is actually in the seat in many cases. So when that bag deploys, you have to replace the seat. Well, how much is an 8-way power seat that's leather with an airbag? $2,500? Oh, we got 2 of them. There's $5,000 in seats. Got the rest of the airbags, and you got to replace the airbag module. Got another $10,000, $5,000 to $10,000 in airbags. We're at $10,000 to $15,000 before we've even started to straighten one piece of sheet metal.
Some manufacturer recommend to change all airbag in case, just even the ones still working.
Right, and that depends. That varies by manufacturer. And you're right, getting hit by an airbag's no fun. But think about how much more you'd feel if the airbag wasn't there and you'd hit the window instead of the airbag.
But
Or
you
hit the
still
steering
break
wheel
your
instead of
legs
the
in the process, so
What's that?
you'll still break your legs in the process, so
Not necessarily. That collision that we saw with the 09 Malibu, the only injury that the driver might have sustained might have been a foot injury to one of the feet. And that was, I mean, that's a pretty substantial accident. So that knee airbag, its purpose is to really prevent. Now, if I'm right up against the steering wheel like this driving, do I have a greater risk of injury than if I have a little more distance and I'm driving what's considered to be the normal distance from the steering wheel? Probably. So that's why we're probably seeing some steering wheels now that the steering column, we've had this going back to the 70s, but now they're powered, where the steering column actually moves in and out. Because they understand that not everyone's the same height. So I need to move my seat closer to reach the pedals. Well, now I'm so close to the steering wheel, it makes an unsafe situation. So I need to be able to lower the steering wheel. Or another solution is, how about if I just make the pedals come closer to you and I have adjustable pedals? So different manufacturers have addressed that differently.